This is the solution video for problem set 6, problem 1, and I will be doing parts A, B, and C in this video, and we'll be doing D in the next. So we start off, and this is basically something you've already done before, and it's a cross-coupled NAND, and basically we just need to figure out how Q changes with respect to A and B. So when A and B are 0, I'm actually going to do this part in pencil so I can actually erase. Let me grab one. And so if this is let's actually not start with 0, 0. I don't want to do that. Let's start with 0, 1. So if A is 0, B is 1, what I find is that if I put my truth table for NAND, so A, B NAND is 0, 0, 0, 1, 1, 0, 1, 1. This is just going to be 1, 1, 1, 0. So anytime I see a 0, I can now put a 1. So this will make Q bar 1, and Q will be 1 NAND with 1, which will make it 0. So we can make this one officially 0. Then, if I do something different, let's actually, if I change this to 1, so now I'm doing AB equals to 1, 1, I see that this value is going to hold. So I have 1 NAND with 1 is 0, 0 with 1 is going to output 1. Good. So that's done. So that's a hold, and then I'll show that it also works the other way. So let's change this to 1, 0. So A is now 1 and B is 0. So we got 0 NAND with 1 is going to output. Am I doing the same thing over again? No. 0 NAND with 1 is going to be 1, but 1 NAND with 0 is going to change this to a 1. And then 1 NAND with 1 is going to change this to a 0. 0 NAND with 0 is 1. And so this will stay the same. So this will now stay the same at a set. And if I change this again back to a 1, I have 1 NAND with 0, which is 1, good, and 1 NAND with 1 is 0, so that also stays. So I can officially say that this is a hold state, and then this, if I change this to 0, 0, this is going to output a 1 on both Q and Q bar, because this is supposed to be Q bar, which means that's a forbidden state. So I'm going to leave that there, because we're going to want to refer back to that later. So now, moving on, suppose we added the following NAND gates to the AB latch. Complete the next state table for the circuit. So I know how this is going to behave, so I just need to figure out how this is going to relate to that. And so, essentially, whenever my clock is 0, this is going to be a 1, and this is going to be a 1. So, when C is 0, this will be 1, and this will be 1, no matter what happens. So I'm always inputting a hold during C equals to 0. So this is going to be equal to Q, and this is going to be equal to Q. Now D, when C is 1, will determine the value of these functions. So this is 1. So when D is 0, 1 NAND with 0 is 1. 1 NAND with 1 is 0. So that, if I follow what I had here, A, B is 0, 1, 0. So that's going to make this equal to 1. And then, let me see. What am I doing? So now I need to put D equal to 1 here, and I've got 1 and 1, so okay, 1 and 1 is going to output a 0, and then 0 NAND with 1 is going to output a 1. So I've got A is equal to, essentially A is equal to 0, B is equal to 1, which is going to be my reset. I realize there's actually a mistake in this. This Q should have been put up here. but this is regardless the correct answer. So, moving on though, hopefully that's not going to be a confusion later. Hate when I realize these things after I've finished solving the problems again. So, D, using this definition here, so I'm going to use the definition that we used in class for the gated D latch, which is when D receives 0, we should output a 1. We should output a 0, and when D is a 1, we should output a 1. And so, because that's what this should have been. Sorry about that. So this is the solution. So if this was done correctly, basically we're going to start with Q equal to 1. So we're going to do that up until the first clock edge. So I know this one can't change until it's so this one will store the value at when the clock is 0, and this will store when the clock is 1. And so during 0, this receives a 0, so it's going to output a 0, and then D, actually no, this is actually fine. So this is actually correct. This is actually okay. This is no problem. So I've forgotten something. Okay. So, starting over, so using this truth table, when the clock is 0, this is going to store the D and change Q to 1. When the clock changes to 1, this 1 is going to be input into here, and we're going to spit out a 0. So this is going to drop down at the clock edge, and it's going to change, it's going to stay, because this one's not going to be changing until the next clock edge. So get this next clock edge, and then, so we're looking at that. So D comes in during the 0, and gets, when clock is 0, and gets stored, so D was 1, so that means this is going to be 0, and then this gets stored into here when it becomes 1, so 0 becomes a 1, and this goes up till the next clock edge. Then D is 0, so D gets stored in, D gets inputted, and Q becomes 1 when the clock is 0, and when the clock is 1, this will change this value, so 1 gets put in, so Q changes to 0, so this goes back down to 0. And then the next question asks, is this D flip-flop master-slave, positive edge triggered, or negative edge triggered? Well, because we have the logical setup of a master flip-flop here, or master latch here, and a slave latch here, we know this is master-slave. Even though it changes only on the positive edges, the logical setup tells us that it's master-slave. And that concludes this video.